Guys, you can see our code starts from 2 3 2 3, but if we go to the code, you will see that in the code we just initialize the LCD, and then we wrote this command called LCD out 1, start writing from first row first column, and then after 2 seconds clear the screen, and then show 2 similarly, and then show 3 similarly. But the thing is that on the LCD you can see we only see 2 and 3, we do not see 1. Why? Because we have used the Goto statement. See, the Goto statement we wrote here, as soon as the forever loop starts, Goto statement tells the program counter that instead of going here, you go to the next one, this identifier, and this is here. We just skip this part using the Goto statement. Then the code continues onward from here. So this is how in this code the Goto statement has been used. Guys, welcome to learning microcontrollers. In this video I will show you how we can use a Goto statement in MikroC for PIC. Demo will be using PIC16F877A and LM016 16x2 LCD. So let's first set up our demonstration hardware. So guys, this over here is the PIC16F877A. This is an LCD 16x2 LM016. Let me show you how to interface it first. Now to connect it, you will need a 3-pin potentiometer, 10 kilo ohm value. It will be needed to adjust the contrast of the LCD. It has 3 pins, 1, 2 and 3 mentioned on its body. Now for the LCD you have 16 pins, 1 to 16 if you hold it like this. Now pin number 1 and 5 you short them together, then you send it to the pin number 1 of your potentiometer. From there you send it to to the ground pin of your PIC like this. Pin number 2 is the VDD of the LCD connected to pin number 3 of your potentiometer. From there you send it to VCC of your PIC. In this way, whatever source is powering up the PIC, like whatever source gave 5 volt to the PIC16F877A, will also give 5 volt to the potentiometer and to the LCD as well. So all three will be powered up from the same source. Now pin number 3 of the LCD is the contrast adjustment pin. You connect it to the adjustable pin of your potentiometer. In my case it is pin number 2. Pin number 4 is the RS pin. You can use any available GPIO pin of your PIC to connect it with. So I'm going to use a pin number D1. For the pin number 6 of the LCD, it's EN pin. I'm going to use D0. Leave 7, 8, 9 and 10. Directly go to pin number 11, which is data pin 4. I will connect it to the port D, pin 4 of the PIC. For data pin 5, that is pin 12 of the LCD, I connect it to port D, pin 5. For pin number 13 of the LCD, I connect to port D, pin 6. Pin number 14, which is the data pin 7 of the LCD, I connected to port D, pin 7 like this. In this way, all the pins are connected regarding the data. Now these pins 7, 8, 9 and 10, they were for the LCD data pin 0, data pin 1, 2 and 3. These pins are required in case you are going to use this LCD in the 8-bit mode, while we are going to use this LCD in the 4-bit mode. So we do not need these pins in our application, because in our application 4-bit mode is more than enough. Now pin number 15 is and 16, they both are for the LCD backlight. Connect the pin number 15 to positive 5 volt, 16 to ground. The same source which is powering up the PIC will power up the LCD's backlight. So in this way LCD will get its backlight on as well. So this is our simple setup hardware. So let me introduce you to the hardware, then we move on to the programming. This over here is the hardware. You can see this is the LCD, behind it is the PIC and the PIC3. You can see rest is just a trainer board. So this is the simple hardware we have here. So let me open the MikroC for PIC. This is the MikroC for PIC. Let me zoom in. If you don't have this software, you can go through the video I have in the introductory section, where you can just go through that video and it will show you how to download and install this for free from the official website. Version 7.2.0 is the one I'm using. You will get the latest, so just get that. Click on new project. This window pops up, new project wizard. Click on next, write the name of the project. So I write here Goto statement tutorial. Okay, the path where your files will be created, select the microcontroller. I have PIC16F877A. The crystal you have connected to pin number 13 and 14. I have a 16 MHz crystal there. So I select 16, click on next and finish. So here we go. Okay, now the next thing is, before you do anything else, go to file and click on save to save your work. This window pops up, save. Okay, it's saved. Now first of all, we initialize the LCD. To initialize the LCD, go to the right. In the MikroE libraries, you have to expand it, expand the system libraries, go down, there is the LCD command. this library, check mark this, expand it. There you have this command called lcdinit. Double click on this. This window pops up. In the example here, you have these commands. You copy them till here. Paste it above the void main like this. Here guys, you will select the pins that you have selected on the hardware. For the RS, I have selected pin number D1. For the EN, I have selected D0. If you have selected some other pins, just this is the difference. You just have to remap them here. For the D7, I have selected port D, pin 7. For the D6, I have selected port D, pin 6. For D5, I have selected port D, pin 5. For D4, port D, pin 4, like this. Now guys, do exactly the same here. That is the pin direction. That was the pinout setting. For the pin direction, same. For the RS, we have D1, D0 for the EN. For the D7, we have port D, pin 7. For data pin 6 of the LCD, we have port D, pin 6. D5 for D5, D4 for D4, like this. Now again, go to the right in the LCD init command library. Double click. Okay, double click. This window pops up. Go down. There you have this lcd init command. You copy it, paste it in the void main like this. Below there, give some delay. I always suggest you give delay in the one-time loop. Not necessary, but I always suggest you do it. Now this command will initialize your LCD with this pinout setting. Now guys, we have the LCD initialized. We go for our forever loop. Forever loop starts here. Forever loop ends here. So first of all, you know what is a Goto statement. If you want to know more about the Goto statement, go to help. Click here. Here you in the search bar just write Goto. It will open up the Goto statement, this one. Now here it will explain to you what is Goto statement in MikroC for PIC. See, Goto label. The Goto statement in MikroC for PIC is exactly the same as for all the C programming compilers like Dev C++, Visual Studio, whatever you have. Even the Arduino IDE have exactly the same way. The STM32 Cube IDE, they all have exactly the same. Even the AVR Studio, whichever the compiler you have using the C or the C++ language will have exactly the same Goto statement label or Goto statement technique to use it. So you just write the Goto, then you write the identifier, you give semicolon, and then where you want to end, you do this. You write that identifier name, and instead of semicolon, you will use double colon like this. So this is what you do. So we will just, I give you an easy demonstration of how I will use it. So I write something, go to the LCD library, let's display something on the LCD. LCD out command, there we have the LCD out command, we have hello. Okay, hello here, hello. Okay, now this is hello. It will start writing hello from first row and first column. It will write hello. Okay, now what I do is that if the code runs right now, you know what it will display. It will display hello. That is what we know will happen as per this code. Then we okay, let's build and let me show you what we get from this code. Okay, I build this code. Then I will do the changement. I will do some changes and I will add the Goto statements as well. Okay, go to PIC programmer tool. If you don't have this tool, I also have a lecture in the introductory section. You can go through that lecture to get this tool for free. It's a free software, so no need to worry. Click on tool, check communication, because I connected the PIC after turning on the software. So then you have to do this. Here you go, detected. Select the microcontroller, PIC16F877A. Here you go. File, import hex file. There is the Goto statement. This is the command, code we just created. Click on write. Wait. Okay, it is programming. Let's go to the hardware and see what happens. It is programming. Let it program. Okay, power up the circuit using a PIC3. Okay, here you go. It is showing hello. Okay, this is fine. We are getting hello as expected. Now guys, what we do is that we add a command to clear the screen. LCD CMD LCD clear. This is a command. In the LCD library, you have this command called LCD CMD. You open this. There you have this command LCD CMD LCD clear. I paste it here. and below them I give some delay. Like it will show LCD out hello for 2 seconds. After that it will clear the screen, and the screen will remain clear for 200 milliseconds. So we modified this code, and this is a new code. Okay, I burn it. Okay, right click on write. The new code is being uploaded. Wait. Okay, let's see what happens this time. Still we have not used the goto statement. First just write something, then you will understand why the goto statement is useful. Here you go. Okay, it shows hello, and then see it just clears the screen. It's looking like it's getting refreshed. Basically it is clearing the screen. See, so this is our new code. Now what we do is that we add something else as well. We make this, instead of hello we make it 1. Instead of hello it will show 1, and then after that we show 2, and then we also add another called 3. So this is our new code. It will show 1 for 2 seconds, then it will clear the screen, then 2 for 2 seconds, then clear the screen, then 3 for 2 seconds, and then will clear the screen. Okay, we build this code. Okay, change code. The new code is here, so let's burn this. Okay, click on write. Okay, it is burning the new code. Now see, we are getting something to play with. Okay, until it's completed I give you description of what I want. Okay, 1, 2 and 3. Now we will use the goto statement. Now goto statement allows you to do jumping and play with the your program counter. Your program counter basically is sequential. In case of microcontroller, it starts executing from 1, 2, 3. It will go sequentially down like this. Now what I do is that goto statement allows you to play with the program counter. You can tell the program counter, no, after this statement is executed, go there. So what we do is that I write goto. This will be the next code. Goto, I write next one, next, go to next. Okay, 1. This is our identifier, and I write next one here. Now instead of 1 it will start directly from 2. That is how I played with the program counter. Now once the code starts, it executes this command. It tells the program counter, no, don't go there, just go to the next. So after that it will start executing from there. So first let me show you without this command the code we already burned. See, 1, 2 and 3. See, it is working like a charm. Now we have added the goto statement. Now as per the goto statement, our code will not display 1 because we are skipping the 1 using this goto command. So I build this code. It's built. Okay, we click on write. Okay, the new code with the goto statement is being written. We have to wait. Okay, it's almost done. Okay, now the code started 2, 3. There is no 1. Why? Because we used a goto statement, we skipped that part. So this can be done conditionally as well. If condition and then go to there, if this, go to there, skip this part, skip that part. So this is how the useful this goto statement is. Now suppose our code came here. Now what I want is that I want to skip this as well. I can write another goto statement. It will go directly here or wherever I want. So this is how you use the goto statement. In this video I have not used a condition, but in future videos I will show you how to use this with the condition as well. So this is it, guys. This is how you use the goto statement. If you have any questions you may ask. We'll see you in the next lecture. Goodbye until then.